Alright, let's take a look at another transformation question. So the point 1,8 is on the graph of y is equal to f of x. Find the corresponding coordinates of this point on each of the following graphs. In the graph that we're given here, y is equal to 0.5 f of 0.5 x plus 3 plus 3. Okay. So in this case, what we want to do first is identify all the transformations, and let's do that in words. And then in the next case, we need to use all of those transformations and create a transformation equation, right, or transforming equation. And this whole process here is mapping notation, right? So let's look at a template of the transform function. Y is equal to a f of k x minus d plus c. We know that a is the vertical modification factor, 1 over k is the horizontal modification factor, d is the horizontal shift, c is the vertical shift, a here is 0.5 or 1/2, k here is 0.5, so 1 over k, which is 1/2, so 1 over k is 2. Okay, so this is the value that we should be looking at. This is the value of a that we should be looking at. D here is -3 and C here is +3. Okay, so the first transformation in words is that there is a vertical compression by a factor of 1/2. So there's a vertical compression by a factor of 1/2, or you can write this as 1/2 f of x. In the second transformation, we're looking at this k value. We're looking at 1 over k, and there is a horizontal expansion or horizontal stretch by a factor of 2, and in function notation we can write this out as 1/2 f of 1/2 x. In the third transformation, we have a horizontal shift 3 units left. So we have a horizontal shift 3 units left. So how we'd write that, 1/2 f of 1/2 x plus 3. So we can see that we're building the function piece by piece by its transformations, its component transformations. In the fourth transformation, we have a vertical shift 3 units up. So we have vertical shift 3 units up, so the way we would write this is 1/2 f of 1/2 x plus 3 plus 3. Okay, so now that we have a collection of all of our transformations, we want to translate this into mapping notation. I want to create a transforming equation. So this is x, this is y, these are the original points of our function or parent function f of x. And if we look at all the transformations we did to our y values or a vertical axis, we had a vertical compression by a factor of 1/2. So we had 1/2 times y. We also had a vertical shift 3 units up, so 1/2 y plus 3. We also had, so those are basically all of the vertical transformations. Let's take a look at some of the horizontal transformations. We had a horizontal stretch by a factor of 2, so you're going to multiply the y value, the x value, by 2, and we had a horizontal shift 3 units left. So you can notice here that I'm just kind of using the modification rules that have to be applied first, and then you do your shifts. Horizontal shift 3 units left, so -3. Okay, so this is your transformation equation. So this is your transforming equation, and this is the whole process of mapping notation. So this is your transforming, let's call it equation. Okay, so now what we need to do here is we need to plug in this point 1 and 8 into the transforming equation. So for x, I'm going to plug in 1. For y, I'm going to plug in 8. Basically, you get 2 minus 3 and 4 plus 3, which is -1 and 7. Okay, so this is your point, your final point on your transformed equation. Okay, so you can do this very straightforward by just kind of by creating the transforming equation and plugging in the original point.